find the design strength in the welded joint if the size of the weld is 5 mm and its effective length is 212 mm. The ultimate shear stress in the weld is 410 Newton per mm square. Assume the connections are made in workshop, that is partial safety factor is equal to 1.25. The first step is you have to write the given data. Step 1, solution. Step 1, given data. That is, so you have to find the design strength in the weld if the size of the weld. So size of the weld is given. Size of the weld, that is S, is equal to 5 mm. So 5 mm must be greater than or equal to 3 mm. Yes, it is okay, it is valid. The second one is effective length. Length is directly given. Effective length is also given. So L suffix F is equal to how much? 212 mm. The next one is ultimate shear stress in the weld. Ultimate shear stress in the weld, that is F suffix U. It is how much it is given in the question? 410 Newton per mm square. And also partial safety factor. The partial safety factor is given in site, means you have to take 1.50, but here it is given as workshop. So gamma is equal to how much? Gamma is equal to 1.25. So step 2, size of the weld must be greater than or equal to 3 mm, that is 5 is greater than 3 mm, hence it is valid. Step 2, you have to find. Step 3, effective length. Effective length is how much? 212 mm. Step 4, ultimate stress, that is Fu is equal to 410 Newton per mm square. Step 5, we have to find design stress in the weld. Design stress in the weld. So FWD is equal to how much? Fu by under root 3 into what is partial safety factor? 1.25. This is the formula to find design stress in the weld. So 410 by root 3 into 1.25. So what is the answer? Let us find it now. So 410 divided by root 3 into 1.25. So what is the answer? 189.37 Newton per mm square. So far we have found design stress in the weld. So what is the first step here? You have to write the given data. Second one, step 2, that is whether the size of the weld is greater than or equal to 3 mm. Step 3, effective length. Step 4, ultimate shear stress in the weld, that will be given in the question. Step 5, we have to find design stress in the weld. FWD is equal to Fu by under root 3 into 1.25. Why did I take partial safety factor as 1.25? Because in the question it is given that assume that the connections are made in the workshop. For workshop, the partial safety factor is 1.25, whereas for site, the work is done in the site, means we have to take partial safety factor as 1.5. Now the last and final step, you have to find the design strength. The last step is that is step 6. Design strength in the weld. P suffix D is equal to 0.7 into size of the weld into effective length into design stress in the weld, that is FWD. So this is a formula to find design strength in the weld. So 0.7 into what is the size of the weld given in the question, that is 5 mm. What is effective length given in the question? 212 mm. What is design strength? Design stress we found in step 5, that is 189.37 Newton per mm square. Let us find the design strength. 0.7 into 5 into 212 into 189.37. We got 140.5 kilonewtons. That is approximately 141 kilonewtons is the design strength in the welded joint. This is the answer. So what is the answer? 141 kilonewtons is the design strength. So design strength is equal to design strength in the weld, P suffix D is equal to how much? 141 kilonewtons. This is the answer. So find the safe load that can be transmitted by the fillet weld joint as shown in the figure. The size of the weld is 6 mm. The ultimate shear stress in the weld is 410 per Newton mm square. Assume that the connections are made in workshop. That is partial safety factor is 1.25. So this is a figure given in the question. So welding is done from here to here, here to here, here to here. So what is the first step? You have to write the given data. Step 1. Given data. So what is given in the question? Size of the weld, that is S is equal to 6 mm. Next, ultimate shear stress, that is Fu is equal to 410 Newton per mm square, and length L1 is equal to 75 mm from here to here, L2 is equal to 60 mm, L3 is equal to how much? 75 mm. So what is total length? Total length is equal to 75 plus 60 plus 75. So 75 plus 75 150, 150 plus 60 210. So the total length is equal to 210 mm. Still what is given? Partial safety factor, that is gamma m0, that is 1.25. Why? Because the connections are assumed to be made in workshop. So that's why the partial safety factor is 1.25. The second step is step 2. Let us check size of the weld, whether it is greater than or equal to 3 mm. So 6 mm is greater than 3 mm, hence it is valid. Step 3, that is ultimate shear stress. So Fu is equal to 410 by Newton per mm square. Step 4, we have to find L effective length, that is L effective length is equal to total length. Total length, that is 210 mm, that is 210 mm. Step 5, design stress in the weld. Design stress in the weld, that is F suffix WD. So F suffix WD is equal to how much? Fu by root 3 into partial safety factor. What is partial safety factor given in the question? That is 1.25. So 1.25. So what is Fu given in the question? 410 by root 3 into 1.25. So what is the answer? I think 189.37 is the answer for design stress in the well. Let us check it. 410 divided by root 3 into 1.25. Yes, 189.37 Newton per mm square. This is called design stress in the well. So far you have found up to the step 5, that is design stress in the well. So the next step is we have to find the design strength, that is last step, step 6. So what is step 6? You have to find design strength in the well. Step 6. Design strength in the well, that is P suffix D is equal to 0.7 into size of the well into L effective length into design stress in the well, that is F suffix WD. So 0.7 into, what is the size of the well given in the question? 6 mm. What is L effective length? In this condition, L effective length is equal to total length, that is 75 plus 60 plus 70, from here to here, from here to here, from here to here. So 210. What is design stress in the well? In step 5 you have found that is 189.37. Let us find the answer of design strength. Zero 0.7 into 6 into 210 into 189.37. So what is the answer? 167.02 kilonewtons, or approximately we can take 167 kilonewtons. So this is the design strength in the well. But in the question what is given? You have to find the safe load. So what is the formula to find the safe load? Safe load is equal to design load, that is PD by 1.5. That is how much? PD means how much? 167 divided by 1.5. So what is the answer? Let us check it. Let us check the answer. 167.02 divided by 1.5. So what is the answer? 111.34. That is 111.3 kilonewtons is a safe load. So this is a safe load that which that weld can bear. But this is design load, that is safe load. So what is the formula for finding the safe load? Safe load is equal to design strength or design load by 1.5. So 111.3 is the safe load for this given problem. So first step we have to find the given data. Step 2 you have to check whether the size of the weld is greater than or equal to 3. Step 4 effective length. Step 5 ultimate stress. Step 6 design strength in the well. So the design strength is 167 kilonewtons, whereas design safe load, formula for that is design strength by 1.5. Or directly we can write here only 167 divided by 1.5, that is 111.3 kilonewtons. This is the answer. Is it clear?